We're making history here today. We are going to be deploying adaptive in a day. Right now it's about 8:30 in the morning. By the PM peak, about 3, 4 o'clock, adaptive should be on and operational.
Yeah, we're outside of Woods Chapel and Independence Avenue at the first intersection, and it's going to be a stretch of 5 intersections and 4 cabinets, with the centerpiece being the I-470 interchange. So the major goal of this InSync Tesla deployment is to progress traffic in the AM to the interchange and up the ramps, and in the PM to progress traffic away from the interchange, and the commuters can get to the residential areas.
Some of the interesting thing about this particular corridor, and one of the reasons we chose it, is the variety of physical detection mechanisms they have in the field already. We have video detection, we have inductive loops, and a radar detection system. So the InSync Tesla system is able to work with all of those seamlessly.
Today we have 2 engineers working on it and 2 of our deployment technicians that'll be installing it, and then we'll have 1 additional guy that'll be observing it remotely, making sure everything's working properly.
Prior to today, the 2 agencies that we were working with, MoDOT and Lee's Summit, have installed wireless networking systems to allow the communication to occur across the corridor, and they also installed some panamorphic cameras that allow us to view what's going on and will allow them to view their corridor from back in their offices.
Lee's Summit just arrived here to help us put the system into detector mode. Detector mode to us means all the inputs are coming into our system, but then we're just translating right into the controller again to use their timing plans that are already on the controller. The next step after this is to free up the controller and put it into adaptive mode, but we need to do this prior to that step.
The wiring here is non-standard. Fortunately, we can make those adjustments within our software, but we need to know what the pin mappings are. So we're going to get one of the technicians from Lee's Summit to tell us exactly what those pin mappings are, and then we can make those changes in our software. Finally got our first intersection done, and we're done. Intersection's up running in detector mode, and we're going to move on to the next intersection.
Well, here we are at the second intersection. The crew's working on installing the components. The basic pieces that go into the cabinet are the InSync processor itself, the physical wires from the controller into our system, and then additionally a equipment panel that has the power supply and the networking connections, a switch that allows us to hook up the pieces that use the network. The demands on the networks are very low with the InSync system, so we really are able to operate with any kind of a network connection.
Even if the communication goes down, your arterial will not suffer any loss. It'll function even without interconnection between signals.
So we're at the 3rd intersection now. It's taken us roughly about half an hour per intersection.
We ran into our 3rd different controller at our 3rd intersection, so we can work with any amount of controllers on one corridor and work them together. This is the controller right here, and then right next to it is the MMU monitor.
Here at this 3rd intersection, we're encountering our 2nd type of detection mechanism. In this case, it's a radar system. They've got front and side firing radar. At the last intersection, we'll run into the 3rd type, the inductive ground loop systems that will be operating the MoDOT.
So we've just finished intersection 3 at Lakewood and Woods Chapel, and we're going to move on to intersection 4.
This is our 4th and final intersection. It looks like 2 intersections, but it's really one 6-way intersection instead of a standard 4-way. What used to be a few hours is now just a few minutes with InSync Tesla.
The InSync Tesla model has been operating out in the field in different parts of the U.S. We've been testing it, we've been evaluating it, we have been calibrating it, and today it is ready to be released. It is looking at real-time demand every second and optimizing it. All intelligence resides locally. Communication failure, not a problem. Things will break down, but InSync Tesla is designed to mitigate 99% of issues that happen at traffic signals. We want to make a difference to the motorists. We want to bring loved ones safer and quicker to their destination. So if we can provide tools to the traffic engineer where they can plug in a device, configure it, and move traffic the way they want it, we've achieved our goals.
Traffic professionals will be able to optimize corridors quickly and easily, where in the past they were afraid to do it because of the cost involved, because of the time involved, the project expenses. And we're making this to where it's so simple, so easy for them to do that there's no reason to not optimize all of the traffic corridors in a municipality.
At our first Tesla deployment here, 4 intersections, we just wrapped up and it is 4 hours on the dot.
1 year of development, half day of installation, and here's the adaptive turn on right here.
Now that we're back at the office, we can take a look at the graphical depiction of the intersections and what is currently happening at that intersection. As you can see on here, each orange indication is a current vehicle detection, and additionally you can see all the tunnels coming through and the progression coming through the intersection.
Right now everything looks good, and we're just going to be watching it over the next few hours and through the rush hour peak to make sure that it's operating as we expect.
Once we're back from the initial deployment, we can use Central Sync to make any of the adjustments or tweaks that's needed for InSync.